So let's quickly solve the problem on the board. We are asked to get the dimension of force. Before you get the dimension of any quantity, you must know that quantity very well. You must know the definition and the formula. Remember, force is defined as pull or push on a body. And this force, F, is equal to mass of the body times its acceleration. That is, force is equal to ma. If you look at this, okay, look at this. These are the fundamental quantities. Some of the fundamental quantities. Mass is presented with capital M, length stroke distance, capital L, time is capital T. So if you want to get the dimension of any quantity, you must know this. Therefore, force is equal to mass times acceleration. Since force is mass times acceleration, how do we get this? Mass times acceleration, that's mass is a fundamental quantity, but acceleration is not a fundamental quantity. In that case, we are going to derive the dimension of acceleration here. Then multiply it by this mass here. We'll now get the dimension of force. So let's quickly solve that. Remember, you now say but. Since acceleration is not a fundamental quantity, let's derive it. Acceleration is equal to change in velocity divided by time. That is correct. Or acceleration is equal to maybe velocity divided by time, or speed divided by time, or speed divided by, because the dimension of speed and the dimension of velocity are the same. In that case, if you're looking at this now, this speed or velocity is not a fundamental quantity. Therefore, we are still going to derive it. To derive the dimension of speed or velocity, we substitute it here and get that of acceleration, and go over here and get that of force. Therefore, speed is equal to distance divided by time. So since it is distance divided by time, distance is presented with L. We now have L over time is capital T. So this will now give us L T raised to the power minus 1, or we'll write it as L stroke T. This is dimension of speed. So I'm going to substitute the dimension of speed here to get the dimension of acceleration. Therefore, remember that acceleration is speed divided by time, or velocity divided by time. So this will now give us, what is the velocity here now, or speed? Velocity or speed, we got the answer as L T raised to the power minus 1, then divided by time, capital T. So bringing this down, we have L T raised to the power minus 1 divided by T, So using indices here, we have L T raised to the power minus 1. Remember, power here is 1. So we can now say minus 1 because of division sign. So we have L T raised to the power minus 2. This is the dimension of acceleration. So this dimension of acceleration will now be substituted here to get the dimension of force. So let's substitute it here to get the dimension of force. Force is equal to mass times acceleration. Therefore, mass is presented with capital M, and the dimension of acceleration is L T raised to the power minus 2. So multiplying them together now, we'll have M L T raised to the power minus 2. Therefore, this is the dimension of force. Option C is correct. Like my page, share and comment. Thank you so much.